Hi, everyone. Thanks for joining today's session on the convergence of AI and blockchain. My name is Kathleen Wrynn. I am an executive director at JPMorgan. I work in the strategy team within the Chief Technology Office as the strategy lead for distributed ledger technologies, including blockchain. Having spent over 13 years in asset wealth management in multiple roles and across most asset classes, I'm incredibly passionate about the potential for blockchain technology to really transform financial services from an infrastructure perspective and also create new business models and opportunities. So what we're going to talk about, and maybe just actually to highlight as well a little more about background, I actually several years ago took 2 programs at MIT Sloan School of Management, one on blockchain and then right after on AI. So I've been very excited about combining these technologies for a while. So really excited to talk to you guys about this today. I've also been informally and formally in the blockchain space for about 7 years. So, it's very exciting being very involved in the blockchain community to see how much really the combination of AI and blockchain has been taking speed, especially over the past year. So, with that, the purpose is to discuss the converging of these 2 transformative technologies and really the benefits and opportunities that can be realized through it. So just to go through the agenda quickly, as this is an AI conference and one of the first times that blockchain is being discussed as a topic, I want to first give an overview of blockchain and some of the benefits and opportunities of combining AI and blockchain. So for those of you with no understanding, hopefully this is a good background on how it relates to AI. And for those of you who do have an understanding of blockchain, hopefully it's helpful in terms of how AI is being combined with blockchain is being beneficial. We'll then go through 3 key use cases for AI and blockchain, highlight some of the challenges to convergence, and then discuss and spotlight how AI and blockchain fit into the evolving technology computing stack. And I'm not sure why this seems to be flashing a bit, but hopefully we can all deal with that. One disclaimer, the views and opinions shared during this presentation are my own and not those of JPMorgan. Had to get that out there. So with that, what is blockchain? Blockchain is a peer-to-peer distributed ledger that leverages cryptography to validate and link a set of transactions or blocks without the need to rely on a third party. That's a lot. So what we just said is we just discussed 3 different technologies. The first, a peer-to-peer network. So no intermediaries are required in order for peers to be able to transact with one another. The second, a digital ledger. So all participants have copies of that same ledger. Third, cryptographic keys. So when peer-to-peer transactions take place, they can be verified in a secure way. One example that, for anyone non-technical in the audience is thinking of blockchain as a book. So I got this book in the exhibit hall from the Deloitte team. So if you think of a blockchain as a book, and then you think of a block as a page in a book, and you think of blockchain transactions as lines on a page in a book, if we all have the same sequentially numbered book, it's very easy to see when it's been tampered with. So for example, if one person has page 21 missing, you know something's wrong. So that's just a helpful way to kind of place the benefits of blockchain that it brings from a secure and transparent perspective. There are many types of blockchains. So there are public blockchains that have no central authority, hybrid blockchains that have a central authority, but also have permissionless features, consortium blockchains that are controlled by a group or consortium, and then private blockchains that are controlled centrally. There are many unique features of blockchain that are different from legacy infrastructure. So just to highlight a few, I won't go through all of them on the slide, but traceability and auditability. So blockchains are organized in a chronological way where all blocks link to the previous block. And so it's very easy and auditable to look through. They're also tamper-proof, and so it's very easy to detect if anything's been tampered with. They're immutable, which means they're unchangeable. So if a transaction has been verified, it can't be reversed. And one of the key utilities to blockchains is smart contract functionality. So these are essentially self-executing contracts between participants based on predefined terms and conditions. We'll talk more about that in the use cases section. Just one more feature to add is programmability. So really to be able, using smart contracts, to program different processes and workflows without relying on any intermediaries. So with that, AI and blockchain have many individual benefits, and they also have shared mutual benefits. AI, as we all know, can process vast amounts of data. It has significant analytical capabilities. It has faster decision-making and enhances speed of business, and also is great for detecting patterns and anomalies. Whereas blockchain is very secure and transparent of storing and distributing data. It is decentralized in most instances, and it is data integrity because, as said previously, it is immutable. They both share also mutual benefits, being that they're both digitally native, they're both available 24/7, they optimize a lot of operational efficiencies, and they automate repetitive tasks and workflows. And probably the most exciting is they're constantly innovating incredibly this year between AI and blockchain. It's really amazing what's been achieved. And that brings to the market opportunity. From an AI perspective, it's been estimated that AI can contribute 15.7 trillion to the global economy by 2030. And for blockchain, it's been estimated that it can generate 3.1 trillion in business value by 2030. So really a significant opportunity. That brings us to the conversion of these two technologies. Combining these technologies really changes the possibility for how information can be processed, stored, and utilized, fostering more transparent, secure, and intelligent systems. So several examples of these opportunities for convergence are enhancing privacy and security, increasing trust and transparency, unlocking operational efficiencies, creating new business opportunities. Really, the list goes on. Wanted to focus on 10, but won't go through all of them. And that brings us, this all sounds great in theory, but what are actual use cases? So this next slide highlights 20 different use cases for AI and blockchain. These are, to flag, these are industry use cases, not necessarily ones that JPMorgan are looking into. So while we could go into all these for the sake of time, we are going to focus on 3. These 3 use cases were chosen because of the blockchain utility they provide in relation to AI. So they are smart contract automation and efficient decision-making, tokenization and incentivized intelligence, and zero-knowledge machine learning. So going into the first use case, combining blockchain-powered smart contracts with AI-based algorithms can automate decision-making and complex business processes. But let's go first into what are smart contracts. So these are programs that are stored in a blockchain and can run and self-execute without any intermediaries. How they work is you have a predefined contract in which all parties agree to the terms and condition before it's coded. Then there's an event associated with the contract. Once triggered, will execute the contract. Once it's executed, the terms of that contract will automatically execute to all parties. And finally, those transactions are settled and recorded on a blockchain. So that's a quick high-level overview of how smart contracts work. There's a lot of opportunities for integrating AI and smart contracts. So enhanced analytics. So using data of smart contracts to collect data and analysis, to predict future outcomes, to identify patterns, to personalize user experiences, really the list goes on. One use case to think of is supply chain management. We're using smart contracts to track the movement of a good on a value chain, and then using AI and the sensors and other devices that go with that to be able to detect if there's any problems or quality or delays, things like that. A second area is on automation, so really taking manual processes and being able to automate them. A key area here, for example, is in healthcare. So using smart contracts to be able to manage records of what's the word I'm thinking of? Patients' records. And then being able to have AI be able to use the data that's stored there to predict potential risks or issues with that respective patient. And the third area is efficient decision-making. There are 3 kind of use cases I'll just quickly walk through. The first is automated negotiation. So using AI agents to negotiate smart contracts on behalf of users or businesses based on whatever preconditions and constraints were provided by that respective user or business. Another is fraud detection. So AI pattern recognition to be able to identify if there's fraud, and having smart contract clauses be able to intervene there. And finally, data-driven contracts. So here really using key terms in a smart contract to be able to update that smart contract based on what's happening. So for example, with insurance premiums. So these are just several of the examples around how smart contracts can integrate with AI. The next use case, which is very exciting, is tokenization and incentivized intelligence. So really, blockchain-based systems can introduce tokenization and incentivization mechanisms to encourage participation in training AI models. So before going further on use cases, what is tokenization? It's the process of converting something of value into a digital asset whose ownership can be tracked on a blockchain. So these assets can take many forms, and they have been this year. So from real-world assets that are tangible, like stocks or commodities, to intangible like patents or voting rights, to digitally native assets like stablecoins. Just on a side note, in the blockchain space, tokenization, especially in the financial services sector, has been an incredibly exciting theme taking place this year. So we're seeing tons of really exciting developments in that space. So when you think of AI, it's incredibly excited. But for this purpose of this session, we'll focus more on the AI applications for tokenization. And that brings us to the right-hand side of the slide, where thinking of AI models, how historically they've been very centrally trained. When you think of using tokens as an incentive for developing AI models and federated learning to act in a more decentralized way, so users can be compensated for their contributions by providing data or computing power to their respective AI model. Another example is data exchange. So again, users being incentivized through tokens to share data or validate data to training AI models. And the final is just AI governance. So tokens being able to be used to vote on processes or different organizational changes for shared AI models. The third use case, which I personally am most excited about, is zero-knowledge machine learning. So zero-knowledge machine learning enables machine learning model training and inference that is data preserving, verifiable, and secure using a cryptographic primitive called zero-knowledge proofs. So zero-knowledge technology has been a significant breakthrough in cryptography because it essentially allows you to validate something without knowing the underlying information itself. How this is done is through a cryptographic method called zero-knowledge proofs, or ZKPs for short. So ZKPs essentially allow for one party, who's a prover, to prove to another party, a verifier, knowledge of a piece of data without revealing the data itself. So for example, I can prove that I know you're an accredited investor without you providing your net income or your net worth. Or for example, prove you are a citizen of a respective country without sharing the underlying passport details. Or authenticate your access to a certain site without sharing your password details. So really exciting to think about the potentials there, especially as it relates to AI. And ZKPs have actually been historically, have been researched on a theoretical basis for over 40 years, but it wasn't until the introduction of blockchain that really it's allowed for a really practical application. And we've seen a ton of progress on that this year, especially in relation to scalability for blockchain in the form of ZKVMs, which is something exciting if you're interested to look into. But ways ZK technology can innovate machine learning models, there are three ways. First, privacy-preserving machine learning. So one of the most common types of ZKPs is called ZK snarks. Quickly, for the sake of time, what essentially they do, you can verify a proof, and ZK snarks allow for it to be very succinct and very fast. So that's why they're the most commonly used right now. And with privacy-preserving machine learning, you can essentially train ML models on content that is private or sensitive without revealing that underlying information to model creators or users. So especially for industries where information is sensitive or in regulated industries like finance, this is really a very exciting potential to build these models. Another area is verifiable machine learning. Here you can verify different data sets using ZK snarks to prove that a data set has been trained on a certain area. The third area is secure machine learning, and here you can pretty much use, again, ZK snarks to ensure the integrity of a model, that it hasn't been tampered with or potentially replaced with a different model when it's in an untrusted environment, especially when it comes to cloud, things like that. So, these are just a few of the examples, but really, zero knowledge provides so many different opportunities, so it's a very exciting area that I really wanted to ensure, was mentioned. So with all these opportunities, there are also challenges to convergence. I won't go through all these different challenges, but to highlight a few, high computational requirements. So both AI and blockchain are very resource intensive. AI requires a lot of computing power. Blockchain has limitations in transaction throughput. There's also significant cost considerations. So, when it comes to infrastructure, energy, expertise required, it really limits, some potential startups or small organizations. Also, interoperability. This is a problem with blockchain or a challenge with blockchain more broadly, but especially, as it relates to being able to interop with different blockchains and also interoperate with AI tools and platforms. And then finally, access to quality data. AI requires a lot of quality data, and while blockchain can ensure the security and transparency of the line data, it also requires that quality data to train the model to begin with. So where's this all going, the convergence of different technologies? This is a very exciting, I think, visual to just showcase how the convergence of these different technologies can create a more integrated technology stack. So as you can see on the bottom is the data layer. That's really where blockchain is, and that's the distributing computing layer. The logic layer is AI, and that's all around cognitive computing. And at the top, you see the interface layer, which is around physical computing and spatial computing with things like augmented reality, virtual reality, Internet of Things, really any technology that allows for a more immersive experience online. So when you think of it's not just one technology or the other, but really the integration of all these different technologies, what's possible gets much bigger. So with that, thank you all very much for your time. This is my email and LinkedIn if you'd like to connect further. Yeah, happy to connect. Thank you all.